Python's multiprocessing queue pickles every message. Pass a large NumPy array and you're serializing megabytes on every call. Pickling serializes your object to bytes, copies it into the queue, then deserializes it in the receiving process. For large NumPy arrays, that's 2 full copies of your data, and the CPU pays for every byte. The solution is shared memory, a RAM region that multiple processes access directly, with no serialization. Python 3.8 added the shared memory class in multiprocessing.Shared_Memory. Allocate a block in one process, share its name, and the other process attaches to the same physical memory. Wrap it with NUMPY. Dot from buffer for a 0-copy NumPy view. Writes are immediately visible across processes. For simpler cases, a shared counter or a fixed array of numbers. Use multiprocessing.Value and multiprocessing.Array. Value wraps a single type's primitive like an integer or float. Array wraps a fixed-length sequence. Both live in shared memory automatically, so there's no pickling. Need to share a Python dict or list? Use a manager, but know the cost. Managers proxy all access through a background server process, so they still serialize internally. Use them for convenience when performance is not critical. Whichever approach you choose, always protect shared state with a lock. Shared memory has no built-in synchronization. Skip pickling. Use shared memory for buffers, value or array for primitives, and manager only when you need arbitrary Python types. And always lock shared state. Want to get better at answering questions like this? With Interview Mentor, you practice real interview questions out loud. You get personalized feedback and a grade on every answer, and you can track your improvement over time.